Welcome back to Algebra 1. We are doing Chapter 4, Section 8, Functions and Relations. And I'm trying something a little different with the light. Leaving off the overhead light so it doesn't have a glare. I looked through the camera, it looked pretty good. So hopefully you'll get the board will look a little better this time. We'll see. We got natural light, so maybe they'll be good enough. All right. So what we talked about last time is we talked about how weirdly y0 and that symbol are often interchangeable in math. I know, it's weird. But the more you learn, the more sense it will make. Okay? So here we have y equals 2x plus 3, 0 equals 2x plus 3, and this is called function notation, and it's read this way, f of x. So f of x equals 2x plus 3, and those right there all mean the same thing. And we talked about why. It's because it's where it crosses. If you solved it with this being 0, this tells us where the line crosses the x-axis. And then the other thing is this function notation. What's up with it? And yet, remember we said that we really like the y one because we have this button on our calculator that says y equals. If you turn on your calculator and push that button, you'll see that you've got y1, y2, y3, y4, all of these different y's of what it equals. Well, with function notation, instead of doing y1, y2, y3, usually they'll do f of x and then g of x, then h of x to be different equations. And see, your calculator can graph a bunch of different lines on your graph screen at the same time. Okay? Now, there are a lot of equations and you can graph them, but only certain equations get this special title of function. So we want to talk about which ones are functions and which ones aren't. It doesn't mean they don't exist. They exist. It doesn't mean you can't graph them, because you can. But they just get this special designation of function if they meet certain qualifications. Now, why even have this weird function notation? Well, it's a sort of a shortcut way of writing a math problem. Here I have, I'll make these the same. I have f of x equals 2x minus 3, okay? But you can write it this way. F, and instead of putting x, you put something there, and then have the equation. What that means is you're supposed to substitute in whatever's in the parentheses for the x and solve it. So we would put in here 2 times negative 2 minus 3. 2 times negative 2 is negative 4. Minus 3 is negative 7. So it's just a way of writing a math problem. The way we have seen it before is, what is x when, or what does y equal when x equals negative 2? And we are told something for x to be, and then we solve for y. So it's just sort of a shorthand way to write it. Here's another one. This one time they called it g of x, and the equation is g of x equals negative 5x, and this time there's a 0. So what do we do with the 0? We substitute it in for the x. So this is negative 5 times 0, and anything times 0 is, that's right, 0. All right, now then, so certain ones are called functions, these are. And I can tell they are because there are no exponents. I know this is going to be a straight line, and I can tell by looking at it that these are functions. But how you can tell by a graph if something's a function is it passes the dun pencil test, okay? And how the pencil test works is this is the graph of that. 2x plus 3, okay? Because I went to 3 and I put a dot, and then I went up to, that's not very good. I went, let's make it better, up to, I'll have to change my scale here, and over 1. Okay, so it's sort of an ugly looking graph. But, and then I can put my line through it. Now, if this is a function, you take your pencil and you hold it vertically and you slide it along the graph, And if it only touches the line in one place at a time, it's a function. So see, the blue line is touching the black expo marker at only one place at a time. Here's another one. This is something different in math, and as I slide my pen along, it only touches at one place at a time, so this is a function. How about this one? Yep, it only touched at one place at a time, so it's a function. Let's try this one. Uh-oh, it's touching there and there and there all at the same time, so that one is not a function. Okay, let's try this one. Is that one a function? Nope, it's touching, if my pencil's long enough, the top and bottom at the same time. Not a function. Okay, how about this one? Y equals -1. It's the red line. It only touches the pen at one place at a time, so y equals -1 is a function. How about x equals 2? Remember we put a dot on 2 and then say no matter what, and we go up and down, but x equals 2. But nope, it's touching all over at once, so x equals 2 is not a function. All right, now another way to do it. If you have your if-then chart, if it's a function, it can have no repeats in the if column. This could be your x's and y's, it could be in and out, your book calls it. It could be called if-then. It also can be called your domain and range. Those are all the same things. I usually put x and y simple and to the point. But you are not allowed to have any repeats in the x column. So do I have any repeated numbers? Not in the ifs, not in the x's, so this one is a function. It has a repeat in the out, doesn't matter. How about this one? Is this one a function? No. See how there's a repeat of those ones? Not a function. Okay, now here's another one just showing you that this is a regular old y equals mx plus b. How to graph it. This is the y-intercept. That's the slope. You start with your y-intercept, your bare number, and on the y you put a dot there. So I'm going to go 1, 2, 3 and put a dot. Then I do the slope, and it's -1/2. So I go down 1 because it's negative and over 2 and put a dot. And then I've got my line. It goes like that. And is it a function? Yes. Dun-dun-dun. It passed the pencil test. So we're going to do a whole lot more with this once you get to Algebra 2. You're getting just a little taste of it now, but it's not too bad, is it? I think it's all right. Well, I found out that there's a math tutor group that uses the math is fun thing that I'm trying to indoctrinate you with, to make you have this subliminal message so you'll start having a good attitude about math. So I've decided I need to change it because like maybe it's copyrighted or something. So instead I'm going to start telling you math is great. And then you're going to start thinking math is great. I love math. Math is awesome. And before you know it, you're going to love math like me. All right. Math is great. See you next time.